Data acquisitions, we were looking at the data types, the storing and archiving of data, data security, data QA/QC, frequency of data sequestration, and all those data management issues. Did they calculate ET? If so, what method did they use? That was a complaint in the past that if I put the same numbers into different equations, and there are a lot of different ways you can calculate ET, I'm going to get different estimates, and that causes a lot of confusion. Fortunately, in recent years, with our working relationships with the San Angelo, the St. Lawrence Network, the Penn Network, and working with the Texas ET Network, they have adopted the same American Society of Civil Engineers Environmental Water Resources Institute standardized methodology. So we're all kind of, most of us are on the same page as far as our calculation. Equipment used, we talked about sensors, calibrations, maintenance of those sensors, power supplies, lightning protection, all those good technical things. The network, we talked about how many and where are the stations, reliability, length of record, staffing, how much does it cost to operate, where are your sources of funds. Technology transfer, the data delivery. How are you delivering the data? Who are your primary audiences? How are they using the data? So again, the questions went on and on. Other issues, needs, problems that identified. So these discussions were very fruitful. We got a lot of good information. Just for an example, we'll talk about a little bit about the quality assurance, quality control. The Texas High Plains ET Network, the one with which we're mostly familiar. We have automated upload of data. So we get the data from the weather stations, we call them automatically, upload the data. We have visual and graphical inspection of the data by our data guru, Mr. Don Dushek, who's been working with us for a long time. He really knows the data. He can look at it. He can read it. He knows what's going on. Phone call, automated email. If there's a problem with a sensor or a communications, then that's an automated, and then Don will make a phone call to the right person to go fix it as necessary. Similarly, the Texas ET Network has boundaries. They have automated communication errors like we do. They have flags with their data that tell Charles to go look at it visually and find out what's wrong, if it's a sensor problem or if it's some other issue. The main difference that they have is a lot of their stations are cooperator stations, so they'll have an agreement with the cooperator and a signed document that, yes, you agree to maintain the station according to our specifications. And so there's a trust that and an assumption that you will follow that. We manage our own or fix our own stations. There are pros and cons to both of those, of course. Just an example of how that visual graphical QA/QC would work. I could plot the data from different stations, or plot the data, look at it over time, and I can identify things that will jump out. For instance, this is a evapotranspiration calculation, and that light blue line is, you start to see something's going wrong. That one station seems to be losing ET, or it's dropping off, but then I look further at the data and the solar radiation sensor is having problems. So those are the ways that we can identify problems with specific sensors. Data range checks is another management method that we look at highs and lows if the temperature is unreasonable. And it's not uncommon for a network that's run maybe not as actively managed. You may actually have someone who's not familiar with the data looking at it, and they may have a daily high temperature of 300 degrees come in, and it doesn't register that that's a problem. So you have to have someone who knows what they're looking at, a little bit of training. So we have the maximum and minimum values. Another thing that we look at is statistical applications and just kind of seeing data ranges, what's reasonable over time and in the context of the time frame and the location. So we can look at those and kind of get an idea of how we're performing, looking for sensor problems before they become sensor failure. Some other recommendations that we made and came across within our investigation: laboratory calculations, making sure that the data are, that the sensors really are calibrated when they get to the field. Do an on-site intercomparison where you have side-by-side comparisons with the same type of sensor at the same location. Are they giving you the same answer? Automated quality control that is complemented with the manual control, looking at those data. Some guidelines and recommendations for managing the weather stations, as well as looking at the data, are included in several resources. The American Society of Agricultural and Biological Engineers has a weather station standard that is actually under review for revision, and the nice folks at USDA ARS here at Bushland, we've got some good studies set up to investigate some siting effects, and are there ways that we can adjust for tall crops and that sort of thing. So we're looking at updating these standards. We've got participants from several states, Terry Howell, Thomas Marek, and others from Texas, as well as other states are participating in this effort to update that standard as needed. Other standards, the FAO Irrigation and Drainage Paper number 56 and the ASCE EWRI Standardized Reference Equation manuscript, a big book with lots of math, but it's really got some good recommendations in there for the data quality and the citing. Common issues and concerns that were identified by the networks, funding stability is one, and we found that in other states as well, that a lot of the networks are running on shoestring budgets and soft funding. So there's not, I think in the public, there's an assumption that these are state funded and taken care of and invulnerable, but the fact is they're actually quite vulnerable to budgetary constraints. Staffing issues, attracting and keeping qualified people. You've got to be able to pay them. And good people are hard to catch, and they're hard to keep because they get some very good skills, and there are demands for their skills. Sensor accuracy and maintenance, of course, telecommunications reliability. You know, if the county maintenance crew digs up your phone line again, you might be down for a couple of days. Data management and delivery. Standardization, I think we were addressing that to a degree, using similar instrumentation, using the same calculation methodology makes a big difference on getting the same answer and delivering a consistent message. Another thing is educating the public, educating the end users in appropriate application of the data and appropriate interpretation of the information. There's a lot of misinterpretation of the information and misunderstanding, and that's something that we can do a better job in communicating how to use the data, what the numbers mean. So that's an ongoing need. Some recommendations that we came up with, those agriculturally based weather stations need to be validated. Even though you get a number, it's on the web, check it out. You know, make sure, is it a reasonable number? And sometimes we have problems with stations, or we have problems with sensors, and so check that out. Non-ag based stations, again, just be a little extra cautious with some of those. Realize that they may not be sited in a field, in an agricultural environment, that the number that you're using may not be representative. Understand that the weather station network personnel need to be familiar with the data, with the instrumentation, with what the numbers mean and how they're applied. And it helps if they have an appreciation, and we really appreciate our good folks that we've had and do have that do understand and appreciate and are willing to learn the data. Other recommendations, we believe that the data and the ET applications are useful, but we also we recommend that there's a more stability built in the system, and so we came up with some recommendations about how that might be addressed through a stable funding, through an agency taking over this responsibility or outsourcing the responsibility so that those are more reliable. The data are used for a lot of applications, including ground truthing for some high-level research. The guys at Bushland are doing some really excellent work there at USDA ARS. They use the data. Our research folks and our extension demonstrations, our Texas Agrilife Research and Texas Agrilife Extension Service folks use the data in our field demonstrations and our research to interpret the information. So there's a lot of applications there, as well as irrigation management and water resources allocations. And so you can see where whether when you lose a network, there is an impact, and it is noticed.